back when computers still filled entire rooms and many airports could barely handle large aircraft. Engineers were already designing machines so enormous they seemed to challenge the limits of aviation itself. But what would drive a nation to build an airplane with a wingspan stretching hundreds of feet, multiple engines, and the weight of a small convoy of trucks? War, strategic transport, ambition, and an intense race to dominate the skies. On this journey, you will discover vintage giants that carried bombs, troops, vehicles, equipment, and loads no ordinary airplane could ever handle. Get ready to hear thunderous engines, picture massive fuselages, and discover technical solutions that were decades ahead of their time. Stay with me until the end, because the final aircraft on this list was so large, so powerful, and so impressive that it permanently changed the meaning of heavy air transport. Boeing B-29 Superfortress. Introduced by Boeing in the United States in 1942, the B-29 Superfortress was created during World War II for long-range missions. Measuring about 98 feet long with a wingspan of more than 141 feet, it could exceed 138,000 pounds at maximum takeoff weight. Its power came from 4 Wright R-3350 radial engines, each with 18 cylinders and a displacement of approximately 3,350 cubic inches, or 54.9 liters. Together, they produced around 8,800 horsepower and pushed the bomber to a top speed near 357 miles per hour. Like most large propeller-driven aircraft, it did not use a conventional transmission. Its engines worked through reduction gear systems connected to 4-blade propellers, while the retractable landing gear absorbed the aircraft's immense weight during takeoff and landing. Up close, the B-29 stood out because of its rounded nose, enormous wings, and the deep sound of its 4 engines. Inside, it featured pressurized crew areas, remotely controlled defensive gun turrets, and a narrow tunnel that allowed crew members to move above the bomb bays. Its range was another major advantage. Depending on the payload and mission, it could travel around 3,100 miles while flying above 30,000 feet. That allowed it to reach distant targets and operate in areas that smaller bombers simply could not reach. Today, preserved examples in museums show just how advanced and enormous this machine was for the 1940s. And if the B-29 already looked massive, the next aircraft took size to an even more impressive level. Messerschmitt Me 323 Gigant. Few World War II aircraft caused as much amazement on the ground as the Messerschmitt Me 323 Gigant. Developed by Messerschmitt in Germany and placed into service in 1942, it was created to transport troops, trucks, artillery, and heavy supplies to increasingly distant battlefronts. At approximately 92 feet long with a wingspan of more than 180 feet, the Me-323 looked like a giant warehouse with wings. Its maximum takeoff weight exceeded 94,000 pounds, while the large fuselage could accept bulky cargo through 2 doors at the front. Power came from 6 Gnome-Rhone 14N radial engines, each with 14 cylinders and a displacement of around 2,360 cubic inches, or 38.7 liters. Depending on the version, each engine produced close to 140 horsepower, for a combined output of roughly 6,800 horsepower. It did not use a conventional transmission. Each engine drove its own propeller through a reduction gear system, while the huge fixed landing gear, packed with wheels, helped spread the weight across improvised airfields. Even so, its top speed was only around 177 miles per hour. The interior was large, simple, and completely focused on cargo. Depending on the mission and flight conditions, the aircraft could carry around 120 fully equipped soldiers, dozens of wounded personnel, or approximately 26,000 pounds of supplies. When all 6 engines were running, the sound was heavy, uneven, and deafening. In the sky, its silhouette was easy to recognize, but its size and low speed also made the Gigant highly vulnerable to enemy fighters. It was used mainly over the Mediterranean and North Africa, carrying fuel, weapons, vehicles, and food. On some missions, the losses were enormous. especially when the aircraft flew without enough fighter protection over enemy-controlled areas. Despite its vulnerability, the Me-323 entered history as the largest land-based transport aircraft, produced in significant numbers during World War II. And if 6 engines already seemed excessive, the next giant traded dusty runways for the open sea. Martin JRM Mars. Imagine an airplane so large it did not need a runway, because the water itself became its base of operations. Built by Martin in the United States, the JRM Mars first flew in 1942 and was designed as a long-range military transport flying boat. At roughly 117 feet long, nearly 200 feet across the wings, and close to 165,000 pounds at maximum takeoff weight, it looked more like a ship with wings. Its hull allowed it to land on lakes, bays, and coastal waters, greatly expanding where it could operate. Power came from 4 Wright R-33 5D radial engines, each with 18 cylinders and a displacement of approximately 3,350 cubic inches, or 54.9 liters. Together, they produced around 8,800 horsepower and pushed the Giant to a top speed near 220 miles per hour. Without a conventional transmission, the engines used reduction gear systems to turn large 4-blade propellers. Depending on the configuration, the Mars could carry around 33,000 pounds of cargo, or more than 100 military personnel. During World War II, it transported supplies and personnel across the Pacific. Later, some examples were converted into firefighting aircraft, capable of carrying approximately 7,100 gallons of water per drop, a role that extended their careers for decades. Enjoying this journey through the giants that shaped aviation history? Then leave a like, subscribe to the channel, and turn on the notification bell, because the aircraft ahead are even more brutal. If this colossus could turn a lake into a runway, the next aircraft pushed size, weight, and ambition to an even more intimidating level. Blohm Voss BV-238. In 1944, when Germany was already facing severe difficulties during World War II, Blohm Voss sent an aircraft into the air that looked oversized even by military standards. The BV-238 was designed as a long-range flying boat for transport and patrol missions, capable of carrying heavy loads over great distances. Its size was impressive before the engines even started. The aircraft measured approximately 141 feet in length, had a wingspan of more than 197 feet, and stood nearly 43 feet tall. Its maximum takeoff weight could approach 220,000 pounds. Power came from 6 Daimler-Benz DB603 engines, each with 12 cylinders in an inverted V configuration, and a displacement of around 44.5 liters. Depending on the planned version, each engine could produce close to 1,750 horsepower, creating a combined output of more than 10,000 horsepower. Like other giant propeller-driven aircraft, the BV-238 did not use a conventional transmission. Its engines worked through reduction gear systems connected to the propellers, while the enormous hull served as the base for takeoffs and landings on water. Its top speed was close to 264 miles per hour. Watching one take off would have been almost unbelievable. The 6 engines created a continuous roar. The hull moved forward while throwing up large waves, and the aircraft had to slowly build speed before finally leaving the water. Inside, there was room for large amounts of fuel, equipment, and military cargo. The project called for transport missions, maritime reconnaissance, and long-range operations. However, only one complete example ever flew, making it one of the heaviest and largest aircraft built at the time. Its fate was as dramatic as its appearance. The only operational BV-238 was destroyed during the war before the design could enter production. Even so, its scale and engineering solutions turned it into one of the rarest legends of German aviation. If a 6-engine aircraft weighing nearly 220,000 pounds already seemed like the limit, the next machine proved that some giants do not disappear when a war ends. They keep flying for decades. Boeing B-52 Stratofortress. Some aircraft enter history because of one specific mission. The Boeing B-52 Stratofortress accomplished far more than that. Introduced by Boeing in the United States in 1952, this strategic bomber crossed generations and remained in service far longer than anyone expected. At roughly 159 feet long, with a wingspan of 185 feet and a maximum takeoff weight exceeding 485,000 pounds, the B-52 dominated any runway. Its long, swept wings and narrow fuselage created a silhouette that could be recognized from a great distance. In the B-52H version, power came from 8 Pratt & Whitney TF-33 jet engines mounted in 4 pods beneath the wings. They pushed the aircraft to approximately 650 miles per hour, even while carrying fuel, weapons, and equipment for long-duration missions. The B-52 did not use a transmission like a ground vehicle. Power was controlled directly through the engines, while the retractable landing gear used 4 main wheel units beneath the fuselage and small wheels near the wingtips. This system even allowed the aircraft to land slightly sideways relative to the runway during strong crosswinds. Inside, the aircraft felt tighter than its massive exterior suggested. The crew worked surrounded by instruments, controls, and navigation systems, while the 8 engines produced a deep, steady roar during flights that could last many hours. Designed for long-range nuclear missions, it was also used with conventional weapons, for reconnaissance, and as a demonstration of force. Its unrefueled range exceeds 8,700 miles, and aerial refueling extends that endurance even further. Over the decades, it received new radar systems, electronics, missiles, and equipment, while retaining an airframe originally designed in the 1950s. Some crew members have flown aircraft that their own fathers and grandfathers once knew during military service. Few airplanes represent the combination of brutality and longevity as clearly as the B-52. But the next giant was even more extravagant, with 6 piston engines, 4 additional jet engines, and a wingspan that seemed endless. Convair B-36 Peacemaker. When the Convair B-36 Peacemaker first flew in 1946, it showed how far the United States was willing to push strategic aviation. Built by Convair, it was created for intercontinental missions and became one of the largest bombers of its time. It measured about 161 feet in length, stretched nearly 230 feet across the wings, and could exceed 407,000 pounds at maximum takeoff weight. Its wings were so thick that crew members could access some internal areas during flight. Power came from 6 Pratt & Whitney R-4360 radial engines, each with 28 cylinders and a displacement of approximately 4,360 cubic inches, or 71.5 liters. Together, they produced more than 22,000 horsepower and drove rear-facing propellers in a pusher configuration. Later versions also received 4 jet engines beneath the wings. With 10 engines in total, the B-36 could approach 435 miles per hour and travel more than 9,900 miles, depending on payload and operating conditions. The aircraft did not use a conventional transmission. Reduction gear systems controlled the propellers, while the retractable landing gear had to support the colossal airframe on long, reinforced runways. Inside were enormous bomb bays, pressurized crew sections, and tunnels connecting different parts of the fuselage. Noise, heat, and vibration turned every mission into a physically intense experience. Built to carry nuclear weapons during the early Cold War, the Peacemaker never entered direct combat. Its presence alone, however, already served as a powerful demonstration of strength. If 10 engines already sound excessive, the next giant had an even stranger mission, carrying major sections of other aircraft inside its own fuselage. Super Guppy. From a distance, it looked like an ordinary airplane inflated far beyond its limits. Created in the United States by Aerospace Lines and introduced in 1965, the Super Guppy was designed to transport massive components for the space program, especially rocket stages that could not fit inside conventional aircraft. The Super Guppy turbine version measured about 144 feet in length, had a wingspan of approximately 156 feet, and stood more than 46 feet tall. Its rounded fuselage provided a cargo compartment more than 23 feet in diameter, ideal for oversized but relatively lightweight loads. Power came from 4 Allison 501 turboprop engines, each producing close to 4,180 horsepower. These engines turned large propellers and allowed the aircraft to reach speeds near 286 miles per hour. The Super Guppy did not use a conventional transmission. Each engine worked through a reduction gearbox connected to the propeller, while the retractable landing gear supported a maximum takeoff weight exceeding 169,000 pounds. Its most impressive feature was located at the front. The entire nose section could swing open sideways, allowing enormous components to enter the cargo hold. Before that could happen, cables, controls, and connections had to be carefully disconnected. Inside, the aircraft looked like a massive flying metal warehouse. The space was not designed for comfort, but to carry rocket components, aircraft sections, and equipment that would have been almost impossible to move by road. The Super Guppy played an important role in the United States space program and also transported components for manufacturers such as Airbus. Despite its unusual appearance, it proved that an enormous fuselage could solve transportation problems no conventional aircraft could handle. But the next airplane was not impressive only because of its volume. It combined massive propellers, raw power, and the ability to operate where few heavy cargo aircraft could go. Antonov An-124 Antei. In 1965, the Soviet Union unveiled an aircraft that looked as though it had been built to carry anything placed in front of it. Developed by the Antonov Design Bureau, the An-124 Antei was created as a heavy military transport for vehicles, troops, and oversized equipment. At approximately 190 feet long, with a wingspan of 211 feet and a maximum takeoff weight near 551,000 pounds, it became the largest turboprop aircraft ever produced. Its power came from 4 Kuznetsov NK-12MA engines, each producing around 15,000 horsepower. Every engine turned 2 enormous propellers, rotating in opposite directions, a system that made better use of the power and created a deep, unmistakable sound. The An-124 did not use a conventional transmission. Its engines worked through reduction gearboxes connected to the propellers, while the multi-wheel landing gear spread the aircraft's weight and allowed it to operate from less developed runways. Its top speed was close to 460 miles per hour, an impressive number for a turboprop aircraft of that size. Depending on the payload, it could carry around 132,000 pounds and travel thousands of miles. The cargo compartment was large enough for trucks, armored vehicles, partially disassembled helicopters, and major quantities of supplies. A rear loading ramp made the aircraft a true heavy-lift air bridge. Its visual impact was brutal. The 4 pairs of contra-rotating propellers created intense vibration, while the tall fuselage and twin tail made the An-124 look even larger from the ground. Used in military operations, humanitarian missions, and industrial equipment transport, the Antei proved that raw power, long range, and rough field capability could exist in the same aircraft. If this propeller-driven giant already looked impossible, the next machine brought that same brutality into the era of massive jet engines. Lockheed C-5 Galaxy. Few aircraft can make a battle tank look small, but the Lockheed C-5 Galaxy was created to do exactly that. Developed by Lockheed in the United States, it first flew in 1968 and entered service as one of the largest military cargo aircraft ever built. At about 246 feet long, nearly 293 feet across the wings, and more than 837,000 pounds at maximum takeoff weight, the C-5 dominated any airport it visited. Its cargo compartment stretched more than 118 feet and had enough space for helicopters, armored vehicles, trucks, and major pieces of military equipment. Modernized versions use 4 General Electric CF6 jet engines, each capable of producing more than 50,000 pounds of thrust. With that power, the Giant can reach approximately 572 miles per hour and travel thousands of miles, depending on the payload. Like every large jet aircraft, it does not use a conventional transmission. Power is controlled directly through the engines, while the landing gear uses 28 wheels to distribute the aircraft's enormous weight across the runway. The Galaxy has cargo doors at both the front and rear, allowing vehicles to enter through one end and exit through the other. The front section of the fuselage lifts upward, opening the cargo hold as if the entire aircraft had an enormous mouth. The C-5 has served in military operations, humanitarian missions, and long-distance equipment transport. Its ability to carry oversized loads reduced missions that once required several smaller aircraft or weeks of travel by road and sea. Even after decades of service, the Galaxy remains a benchmark for strategic heavy transport. But the final aircraft on this list combined colossal size, raw power, and lifting capacity in a way that placed it among the greatest giants in aviation history. Antonov An-124 Ruslan. In the early 1980s, the Soviet Union needed an aircraft capable of carrying loads that simply would not fit inside ordinary cargo planes. The answer came from the Antonov Design Bureau. The An-124 Ruslan first flew in 1982 and became one of the largest transport aircraft ever built. At approximately 226 feet long, 240 feet across the wings, and more than 65 feet tall, it could reach a maximum takeoff weight of around 893,000 pounds. Its cargo compartment stretched more than 118 feet and could carry up to 330,000 pounds. Power came from 4 Progress D-18T jet engines, each producing roughly 50,700 pounds of thrust. This allowed the Ruslan to reach approximately 537 miles per hour, even while carrying vehicles, turbines, locomotives, and enormous pieces of industrial equipment. Like other large jet aircraft, it did not use a conventional transmission. Power was controlled directly through the engines, while the 24-wheel landing gear distributed the massive weight and helped the aircraft operate from less developed runways. The An-124 could open both the front and rear of its fuselage. Its nose lifted completely upward to reveal a massive cargo entrance, and the front landing gear could lower the aircraft to make loading heavy vehicles and equipment easier. Inside, the Ruslan looked like an industrial warehouse with wings. Overhead cranes mounted in the cargo hold moved heavy loads without relying entirely on external equipment, an important advantage at remote airports and during special missions. Throughout its career, the An-124 transported power plant components, helicopters, generators, and even partially disassembled aircraft. Among all the giants on this list, it was one of the best examples of turning colossal size into real-world usefulness. On this journey, we saw bombers, flying boats, and cargo aircraft so large that they changed the limits of heavy aviation forever. More than machines, these giants represent engineering, ambition, and humanity's ability to turn nearly impossible ideas into reality. Now tell us in the comments, which aircraft surprised you the most? Which one seemed far too large for its time? And which one would you most like to see in person? Leave a like, subscribe to the channel, and turn on the notification bell. That helps YouTube recognize the value of this content, strengthens the channel, and allows more people to discover these incredible machines. See you in the next video.